Bismillahirrahmanirrahim. We will be doing question number 7 of exercise 10.2. Question number 7 is show that cotangent alpha plus beta is equal to cot alpha cot beta minus 1 over cot alpha plus cotangent beta. For this I am going to pick the right hand side and prove that this side is equal to the left hand side. So taking the right hand side, cot alpha cot beta minus 1 over cot alpha plus cot beta. Now over here we know that tangent alpha and cotangent alpha are reciprocals of one another. So cot alpha can be written as, we know that cot of alpha is equal to 1 over tangent alpha. So using this identity I am going to write cot alpha as 1 over tangent alpha, cot beta is 1 over tangent beta, and the same over here. Cot alpha is equal to 1 over tangent alpha into cot beta will be 1 over tangent beta minus 1 over cot alpha, that is again equal to 1 over tangent alpha plus 1 over tangent beta. Now we will take the LCM. What's the LCM over here? This will be 1 minus, the LCM will be tangent alpha into tangent beta, and it will be multiplied to the numerator of here in the second fraction. This will be equal to tangent alpha tangent beta over tan alpha and tangent beta over here, taking the LCM, this will be equal to tangent beta plus tangent alpha over the same tangent alpha tangent beta. So we have taken LCM over here and in the numerator, both in the numerator and the denominator. So this is the expression what we got. Now we know that the numerator has the same denominator as the denominator of the denominator, as these two are same, so we can cancel out these expressions. Okay, and we will be left with 1 minus tan alpha tan beta over tangent beta plus tangent alpha. Now the expression that we got is 1 minus tangent alpha tangent beta over, this can be written as tan alpha plus tangent beta. Now I am going to shift this expression in the denominator, so it will go to the denominator of the denominator. Okay, this is the denominator, and if we shift this expression over here, it will be placed in the denominator of this expression. So this expression can be written as 1 over tangent alpha plus tangent beta over 1 minus tan alpha tan beta. Okay, I have shifted this expression to the denominator. Now from the identity of tangent alpha plus beta, what is the expression for identity of tangent alpha plus beta? We know that tangent alpha plus beta is equal to tangent alpha plus tangent beta over 1 minus tan alpha tan beta, which is the same as this expression. So we can say that this whole expression is equal to tangent alpha plus beta. So I can write this as 1 over, and this expression we can write as this expression as tangent alpha plus beta, and we know that 1 over tangent alpha plus beta will be equal to cotangent alpha plus beta, because cotangent and tangent are always reciprocal of one another. Therefore this 1 over tangent alpha plus beta is equal to cotangent alpha plus beta, which is equal to the left hand side, and this completes the proof. We had to prove that we took this expression And first we wrote cot alpha in the form of tangent alpha. After taking LCM and shifting this expression to the denominator, we got this expression, and this expression was equal to this tangent alpha plus beta. So I have replaced this by tangent alpha plus beta, and what we got is 1 over tan alpha plus beta, which is equal to cotangent alpha plus beta, and this is what we needed to prove. So this completes the proof of this part. Let's move to the next. Now question number 7, part 3. This question number 7, third part, because the second part is the same as the first part. So I am doing part 3 of question number 7. For this we have to prove that this expression, which is in the form of tangent, is equal to sine alpha plus beta or sine alpha minus beta. It means that after taking this expression, we should convert it in the form of sine over cos. We know that tangent alpha is equal to sine alpha over cos alpha. So I am going to convert all these tangents into sine and cosines. Tangent alpha plus tangent beta over tangent alpha minus tangent beta. This will be equal to, we know that tangent of an angle is equal to sine of that angle over cos. Okay, tan theta is equal to sine theta over cos theta. So tangent alpha will be equal to sine alpha over cos alpha, okay, plus sine beta over cos beta. This will be the numerator, and similarly in the denominator, what am I going to do? I am going to write sine alpha over cos alpha minus sine beta over cos beta. Now I am going to take the LCM both in the numerator as well as in the denominator, and we will get the LCM will be cos alpha and cos beta. We will multiply cos beta over here and cos alpha over here. So what do we get here after taking LCM? Sine alpha into cos beta plus sine beta into cos alpha over the denominator cos alpha cos beta over here. Again I am going to take the LCM, sine alpha cos beta minus sine beta cos alpha over the LCM cos alpha and cos beta. Okay. As both these expressions are same, so they will be cancelled out. Okay, and we will be left with the numerator and the denominator containing this and this expression. Okay, now here we are going to apply the identity sine alpha plus beta and sine alpha minus beta. We know that using the identities, sine, we know that sine of sum of two angles is equal to sine of A cos of B plus sine of B and cos of A, and sine of A minus B is equal to sine of A cos of B minus sine of B and cos of A. Now if you observe this expression and this, the right hand side of this, they are exactly the same. Okay, sine alpha cos beta plus sine beta cos alpha. Instead of A we have alpha, instead of B we have beta. So I am going to write this side of the identity for this whole expression. This will be equal to this sine alpha cos beta plus sine beta by cos alpha. By using this identity, this will be equal to sine of alpha plus beta. Okay, and in the denominator, if you compare this identity and this one, okay, they are the same expressions, and this whole expression will be equal to sine alpha minus beta. Okay, and this is the right hand side which we needed to prove. So this completes the proof of this identity. Now let's move to the next question. Now the next question is question number 8. In this it is given that sine alpha is equal to 4 over 5. So we have an angle alpha and its sine is given to us to be equal to 4 over 5. And cos of beta is equal to 40 over 41. Okay. and it is given that alpha lies between 0 and pi by 2. It means this will be in the first quadrant. Okay, beta also lies between 0 and pi by 2, means 0 and 90. So alpha and beta both are in the first quadrant, therefore their sine and cosines will be positive. Okay, show that sine alpha minus beta is equal to 133 over 205. So we have to calculate sine alpha minus beta. The solution is simple. In order to get sine alpha minus beta, we know that by using the identity sine alpha minus beta is equal to sine alpha here. If sine alpha is equal to 4 by 5, sine and cos are given to us, and we have to find sine alpha minus beta. So I am going to use the identity sine alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. As we have sine alpha, but we have sine alpha and cos beta, but we don't have cos alpha and sine beta. Okay, cos of alpha we will calculate it with the help of this sine alpha. Sine beta we are going to calculate with the help of this cos of beta. After getting these two values, we are going to just put it in this expression to get the value of sine alpha minus beta. Okay, so this is the identity that we are going to use. Name it as 1. First of all, I am going to calculate. We have sine alpha and cos beta. These two expressions are given to us, but we don't know cos alpha and sine beta. Okay, in order to calculate cos alpha, cos of alpha, we know that cos square alpha is equal to 1 minus sine square alpha. By the first identity, trigonometric identity, cos square alpha plus sine square alpha is equal to 1. Okay, I am using that identity. So this will be equal to 1 minus sine square alpha will be 4 over 5 whole square. Okay, after finding its value by using calculator, 1 minus 16 by 25, that is equal to 9. This will gives 9 over 25. Cos of alpha will be the positive square root of this. We won't take the negative value of the square root of 9 by 25 because alpha is in the first quadrant, and in the first quadrant cos is always positive. So we are going to take the positive value of the square root of this number. Okay, we are going to take the square root of both the sides, and we are going to take the positive square root because alpha is in the first quadrant, and we know that all the angles which are in the first quadrant have sines and cosines positive. So its value will be 3 over 5. Square root of 9 will be 3, square root of 5 will be 5. Okay, so cos of alpha came out to be equal to 3 by 5. Okay, now we need to calculate sine beta. We know what's the value of cos beta. So we know that sine square beta will be equal to 1 minus cos square beta, and 1 minus cos square beta will be 40 over 41 whole square. Now calculating 40 by 41 square. 40 square is 1600. 1 minus 1600 over, and 41 square is 1681. Now subtracting this fraction from 1, we get, okay, the answer is 81 by 1681. Okay, this is sine square beta. In order to get sine beta, which we require over here, we are going to take the positive square root of both the sides, because sine beta can't be negative as beta is in the first quadrant. Therefore sine will be positive square root of 81 by 1681. The square root of 81 is 9, and square root of 1681, as it is obvious from here, will be 41. So sine beta is equal to 9 over 41. Now we were given the value of sine alpha and cos beta. We calculated the values of cos alpha and sine beta. These four values will help us to calculate sine alpha minus beta by using this identity. So I am going to write this identity and place all these values in it. Okay, let me write cos of alpha. We have calculated it to be equal to 3 by 5. We have calculated that. And sine beta is equal to 9 by 41. Okay. Now I'm going to place these values in the given identity. This is the identity that we are going to use. So I'm going to filter the values of sine alpha cos beta from here and cos alpha sine beta from the values which we have calculated. So sine alpha minus beta will be equal to sine alpha cos beta minus cos alpha is 3/5 into sine beta 9/41. Using the calculator we are going to find this is 160 minus 27/205. Okay, so I'm going to subtract these two. 160 minus 27 is equal to 33, and then it is what we needed to prove. So it means that sine alpha minus beta is equal to 133/205, and this is what they wanted us to prove. So we have proved that sine alpha minus beta is 132/205 with the help of this identity. Okay, we have these two expressions and these two expressions. We could easily calculate with the help of these two by using the first identity. After getting all these four values, place it in this identity to get the value of sine alpha minus beta, which is 133/205, and this is what they wanted us to prove. Okay, this completes the solution of this question. Let's move to the next question. Now in this question, question number 9, it is given that sine alpha is equal to 4/5, sine beta is equal to 12/13. So sine alpha and sine beta are given to us, and it is also given that alpha lies between pi/2 and pi. So in which quadrant would alpha and beta lie? They both lie between pi/2 and pi. It is, we know that the quadrant which is from pi/2 to pi, pi means 180 degrees and pi/2 means 90 degrees. So these angles lies between 90 degrees and 180. It means they both will lie in the second quadrant. So both the angles alpha and beta, we don't know which angle is greater and which is smaller, but that is for sure that they lie in the second quadrant. Okay, so this angle lie in the second quadrant as well as this will lie in the second quadrant. Both the angles lie in the second quadrant. Okay, and they have asked us in which quadrant do alpha plus beta and alpha minus beta lie, and they have also asked us to calculate different quantities as sine alpha plus beta, sine alpha minus beta, cos alpha plus beta, and so on. They have asked us to find different expression. For example, the first part they asked us to find sine alpha plus beta. The method will be the same as we did in question number 8, but take care that alpha lies in the second quadrant, so we will be careful about its the sign of the sign, whether it is positive or negative. Okay, while calculating cosines and sines. So sine alpha is given to us. We want to calculate sine alpha plus beta. In order to calculate sine alpha plus beta, the identity that we are going to use is, we are going to use the identity sine alpha plus beta. We know from trigonometric identities that this is equal to sine alpha cos beta plus sine beta and cos alpha. So over here in the question we are given sine alpha and sine beta. So we have sine alpha and sine beta, but in order to calculate sine alpha plus beta, we will require cos beta and cos alpha, which we are going to, cos alpha can be calculated with the help of sine alpha and cos beta can be calculated with the help of sine beta. So I am going to calculate these two, which will help me to find sine alpha plus beta. So first of all, we know that sine alpha is equal to 4/5, and we know that cos square alpha is equal to 1 minus sine square alpha by the first identity of trigonometry. So I am going to put the value of sine alpha over here. Sine alpha is 4/5 square. This will be 1 minus 16/25, which will be equal to 9/25. Okay, so it means cos square alpha is equal to 9/25. Now alpha is in the second quadrant, and in the second quadrant cos is always negative. So we are going to take the negative. If we take the square root of both sides, we will get plus minus 3 by 5. But I'm going to ignore the positive value because we know that alpha lies in the second quadrant, and in the second quadrant cos is always negative. Therefore, we won't take the positive value. We will just take the negative value because alpha lies in the second quadrant, and the second quadrant cos is always negative. So cos alpha will have the value negative 3 by 5. Now we have calculated cos alpha. The only thing that remains is cos beta. In order to calculate cos beta, I am going to make use of sine beta. Okay, sine beta is 12 by 13. Sine of beta, sine square beta, sine beta is equal to 12 by 13. In order to calculate cos square beta, we know that cos square beta is equal to 1 minus sine square beta, that is 1 minus 12 by 13 whole square. This will be equal to 1 minus 144 over 169, which will give us 1 minus 144 by 169 gives us the value 25 by 169. So cos of beta will be plus minus square root of 25 over 169, which is equal to plus minus 5 over 13. Now again, beta lies in the second quadrant. It is given to us where cos is always negative. So I am going to ignore the positive sign. Okay, and we are going to take the negative sign only because beta lies in the second quadrant. Okay, so its cos will be negative. So now we know cos alpha and cos beta. Okay, I am going to put these two values along with the values which are given to us in this expression to get sine alpha plus beta. So putting these values, let me write it down somewhere over here. Cos of alpha is, we have calculated as minus 3 by 5. Okay, and we are given sine beta and sine alpha, and cos of beta is negative 5 over 13. So after getting all these values, I can easily calculate this expression sine alpha plus beta. We can find the value of sine alpha plus beta very easily now because we have got all the material that we want. So sine alpha plus beta, which they had asked us to calculate, is equal to sine alpha 4 over 5 into cos beta, which we have calculated as negative 5 by 13, plus sine beta is given to be 12 over 13, and cos alpha is equal to negative 3 by 5. So 5 will be cancelled out with 5, and where is it? Negative 3 by 5, 12 by, okay, that's all we have. This will be equal to negative 4 over 13, and here we will have negative 36 over 13 into 5 will be 65. Here we are going to add these two fractions and put a negative sign with the answer. 4 over 13 will be added to 36 over 65 because we have the same signs, and we are going to get negative 56 over 65. So it means that sine alpha plus beta is equal to negative 56 over 65. Now we are going to remember this result because we will need it in the quadrant when we decide the quadrant in which alpha plus beta and alpha minus beta lies. This will help us. Okay, so we will write it down somewhere. Let me take notes over here. Sine alpha plus beta is less than 0. Okay, this is what it indicates because there is a negative sign with it. Now let's do some other parts also. This completes the first part of this question. So sine alpha plus beta, we have calculated it to be equal to negative 56 over 65. Okay, so what conclusion do we have from here is that we concluded that sine alpha plus beta is less than 0. Okay, it's negative. Now Let's move to the next part. The next part is they are asking for cos of alpha plus beta. Again, using the trigonometric identities, cos of alpha plus beta, we know that this is equal to cos alpha cos beta minus sin alpha sin beta. We have all these values. Okay, again we are going to use these four values to get the value of cos of alpha plus beta, which will be equal to, now cos alpha is negative 3 by 5, cos beta is negative 5 over 13, minus sin alpha is 4 over 5, and sin beta is 12 by 13. Now this will be equal to minus minus plus, it will be 15 over 13 into 5 is 65, okay, minus 4 into 12 will be 48 over 65. Subtracting these two, we are going to get 15 minus 48 will be negative 33 by 65. So cos of alpha plus beta is equal to negative 33 by 65. Okay, this completes the second part. And note down that cos of alpha plus beta is also negative. So sine and cos both are negative. Cos of alpha plus beta is less than 0. Okay, I am writing this because we are going to decide the sign for alpha plus beta and alpha minus beta at the end, after getting enough information about sines and cosines. Okay, the next part is, the third part asks us to find tangent alpha plus beta. Tangent alpha plus beta we can easily find with the help of sine alpha plus beta over cos alpha plus beta, because we know these two values, sine alpha plus beta was equal to negative 56. This was equal to negative 56 over 65, and cos alpha plus beta we have calculated it as negative 33 by 65. The negative signs will cancel out, it means tangent alpha plus beta will be a positive quantity, and that is 56 over 33. So note down that tangent alpha plus beta is a positive number. Okay, tangent alpha plus beta is greater than 0 from this information. Now let's do the remaining parts. Let's get some information about alpha minus beta. These things are enough to decide the sign of alpha plus beta. Now let's move to the next part. The next part, they are asking for sine of alpha minus beta. Okay, this is the fourth part. Yes, sine of alpha minus beta. Okay, then the fourth part we have to calculate sine alpha minus beta. We know that sine alpha minus beta is equal to sine alpha cos of beta minus sine beta cos of alpha. Again, using the same four values, we are going to just put their values in here and calculate sine alpha minus beta. Sine alpha is 4 over 5 into cos beta is negative 5 over 13 minus sine beta is 12 by 13 into cos of alpha, where is it here, negative 3 by 5. So this will be negative 20 over 65, and here it will be plus 36 over 65. So we are going to get a positive value. Okay, 36 minus 20 will be 16. So the answer will be 16 over 65. So it means that sine of alpha minus beta is equal to 16 by 65. So note down that sine alpha minus beta is a positive quantity. Okay, from this expression, sine alpha minus beta is greater than 0. Okay, and the next part is part 5, cos of alpha minus beta. We have to calculate cos of alpha minus beta by using the same trigonometric identities as before, cos alpha cos beta plus sin alpha sin beta. Okay, we are going to use this identity. Now cos alpha is, again using the same values, negative 3 by 5, cos beta is negative 5 by 13 plus sin alpha is 4 over 5 into sin beta is 12 by 13. Now this will be will be equal to 15 over 65 plus 48 over 65, and this is going to be equal to 15 plus 48 is 63, so it is 63 over 65. So we have calculated cos alpha minus beta as 63 over 65. So cos alpha minus beta is also a value which is greater than 0. Okay, the last part is to calculate tangent alpha minus beta. We know that tangent alpha minus beta can be written as sine alpha minus beta over cos alpha minus beta. We have calculated sine alpha minus beta over here and cos alpha minus beta over here. I am going to put the values of these two to get tangent alpha minus beta, which will be equal to now tangent alpha minus beta, putting the values of sine alpha minus beta 16 over 65 and cos alpha minus beta over here is equal to 16 by 63. So tangent alpha minus beta is a positive quantity. Now from this we can calculate, let me rewrite all this again clearly so we can decide the sign of. Now sine and cosine both are negative and tangent is positive. This is possible only when alpha plus beta is in the third quadrant. Okay, so alpha plus beta is in the third quadrant, because in this quadrant tangent is positive and both cosine and cosines are negative. Coming to alpha minus beta, all sine, cosine and tangent are possible. All these three are